Here we are required to solve for x in this equation. This can be called an exponential equation because the variable, which is x, is in the exponent, okay? Because 5 is the base, and here you have 3x is the power. X is part of the exponent, so you have an exponential equation here to solve. Now you can recall when you are solving equations, to solve for x, you have to cancel out the numbers that on the same side with x, because at the end of it, what you want is x is equal to, you want x by itself. Now there is a 5 and a 3 on the same side with x, but the 5 now is a base and the 3 now is part of the power. How are we going to solve? You know for sure if the number is adding to x, you subtract it. If the number is subtracting to x, you add it. If the number is multiplying to x, you divide. If the number is dividing to x, you multiply to cancel it out. But you have the number is a base and x self is an exponent. You can only do those adding, subtract, multiply, divide if x is on the same level. Look at where x is. X is in the air. So we need to apply this rule of logarithms. Okay, I know it often, but I'm just going to show you where you can easily get it. Okay, so you can just punch in Google, type in Google the rules of logarithms. 3 rules of logarithms. One is adding, one is subtracting, and one is powering. Okay. And here they are, right there. The product rule, the quotient rule, and the power rule. Now the product rule, we just talked about product rule and quotient rule in differentiation, so please don't confuse. If those 2 letters are multiplying, you can separate them by adding. If those 2 numbers are dividing, you can separate them by subtracting. But if now you have one letter alone as a base and another letter as a power, then you can apply what you call the power rule. Okay, so take note of the power rule. Okay, take note of the power rule. So logarithm in a particular base, the base here is not written. Okay, if a base is not written, it's 10. So really and truly, this is supposed to be written as a logarithm in a particular base, okay, of a letter raised up to a power. Let's call it n. If you have a situation like that, that power, that exponent, can come in front of the L for the logarithms and of the letter by itself. Okay, so that is what this rule is actually saying. Okay, so now we're going to apply this rule now for want of a better way of saying it, bring down the 3x. Okay, bring it down in front of the L. Now remember, we have 10 is equal to 5 raised up to 3x. Okay, remember we said whatever you do on one side, you do on the other side. If I multiply, and I put this in a bracket just to prove a point. The golden rule when you're doing algebraic processes, whatever you do on one side, for the balance to maintain, you must repeat it on the next side. If you divide on the right, you have to divide on the left. If you multiply on the left, you have to multiply on the right. Okay? So let's say if I multiply 27 to 10, I have to multiply 27 to 5, 3 to the x. if I multiply 10 by pi, I have to multiply 5 raised up to 3x by pi also. If I add pi to 10, I have to add pi 5 raised up to the 3x. So therefore now, if, oh, and also if I write THE, if I write THE in front of 10, I have to write THE in front of 5 raised up to the 3x. Whatever I do to 10, I have to do it to 5 raised up to the 3x. Okay. So therefore now, if I write LOG in front of 10, okay, and by the way, LOG is not a variable. LOG is like saying cosine. For example, if I write cosine COS by 10, I have to write COS by 5 raised up to the 3x. Okay, and we know what COS stands for, cosine. So if I write LOG in front of 10, I have to write LOG. And LOG now, that's the base of 10. I can also write LN. If I write LN, I have to write LN in front of 5 raised up to the 3x. LN is LOG to the base of E. Okay, remember that. Okay, so here I can use either LN or LOG because it doesn't matter what is the base. Once it's the same. Okay. So therefore now, and I can use ln because most scientific calculators are programmed for natural logarithms. So we can use ln. Okay, so that means log to the base of e. Now, since we know what logarithm is and we know the power rule, so in the next step now, this allows us now to take this 3x from up there and write it in front of the L. Okay, by applying that power rule. So right now, 3x is multiplying to ln of 5. Okay, and we are continuing the same rule. What we do on the right, we have to do on the left. Okay, so I have to divide by ln of 5 to cancel out ln of 5, and not just ln of 5 alone, 3 ln of 5, because the 3 can cancel out one time. Okay, the ln of 5 cancelled out and the 3 cancelled out to leave the x by itself. Remember, we want our final answer to be x is equal to. Okay, so if I divide by ln of 5 by 3 ln of 5 on the right, I have to divide by 3 ln of 5 on the left. Okay, 3 ln of 5 cancels out from the right side. And we just said if x is equal to, and we can certainly find what is ln of 10 divided by 3 ln of 5. Also bear in mind, instead of writing ln, we could write log to the base of 10. Okay, so you have an option, either use log to the base of e or log to the base of 10. It doesn't matter what base you use, once it's a log. And we all know that whenever you say log, there must be a base. Okay, if you don't see a base written, the base is 10. Okay, because the rules say in any base b. Okay, so you check your scientific calculator and look for ln. So here it is, ln natural logarithms of 10 divided by 3 ln of 5, and that should give us our answer. .235. right? So please make sure that you can apply this power rule to solve logarithmic equations. Exponential equation, sorry.